Bismillahirrahmanirrahim. Dear students, welcome to the Electrical Engineering channel. In this lecture, I will discuss the rank of a matrix. And the rank of a matrix is defined as the maximum number of linearly independent column vectors in the matrix. And if a matrix has R number of rows and C number of columns, then if R is less than C, then maximum rank of the matrix is R. Similarly, if R is greater than C, then the maximum rank can be equal to C. So, if a matrix has three rows and four columns, then the maximum rank can be equal to 3. Similarly, if a matrix has five rows and five columns and nine rows, then the rank can be a maximum of 5, right? So the minimum or the lower value of either the number of rows or columns, the maximum rank can be equal to the lower value. Either it is the number of rows or the number of columns. And the rank of a matrix would be 0 only if the matrix has no elements. If a matrix has even one element, its minimum rank is 1. And if a matrix has even one element, even if that element is equal to 0, still its minimum rank will be equal to 1. And the 0 rank of a matrix can only occur if it is an empty matrix or if the matrix has no element. And now I will discuss some forms of a matrix. Echelon form of a matrix. The first thing is the row echelon form. Second is the column echelon form. And third form is called row reduced echelon form. Now we will discuss these forms of a matrix one by one. A row echelon form is a matrix when it satisfies the following conditions. The first non-zero element in each row called the leading entry must be equal to 1. So this is the first condition for a matrix to be in row echelon form. The second condition is that each leading entry is in a column to the right of the leading entry in the previous row. And the third condition is that rows with all zero elements, if any, are below rows having a non-zero element. Okay, so these are the three conditions, and if these three conditions are satisfied, then the matrix will be said to be in row echelon form, and these are some examples. So we will start from the left hand side and inspect each row. In the first row, the first entry is equal to 1, so this condition is satisfied. In the second row, this is the leading entry and this entry is lying right to the leading entry in the first row. So this condition is also satisfied. In the third row, again the leading entry is equal to 1 and it is lying at the right side of the leading entry in the previous row, which is second row. Now let's check this matrix. So starting from the left, this is the leading entry which is equal to 1. This is leading entry and it is equal to 1. This leading entry is also equal to 1. And here we have a row of all zeros and it is below the row. Uh, it is below the row in which only one entry is non-zero. Okay, so this third condition is also satisfied. So let's check this matrix and starting from the left hand side, this is the first row leading entry is equal to 1. In the second row, this is the leading entry which is equal to 1 and it is at the right hand side of the leading entry in the first row, and this is the third row which is a row of complete zeros. So all these three matrices are examples of echelon form. Now we will discuss reduced row echelon form. So a matrix will be in a reduced row echelon form when it satisfies the following conditions. The first condition is that the matrix satisfies conditions for a row echelon form. So the matrix must satisfy all the conditions of a row echelon form. And the next condition which must also be satisfied is that the leading entry in each row is the only non-zero entry in its column. Okay, so let's check few examples. This is the leading entry of the first row and it is equal to 1. And this is the leading entry of the second row and it is also equal to 1. This entry is lying at the right hand side of the leading entry in the first row. So this condition is also satisfied. Now we will have to check the column of the leading entry in all the rows. So here this is the leading entry and it is only the non-zero element in this first column. So this leading entry is lying in the third column and it is the only non-zero entry in the third column. And in the third row, this is the leading entry. It is lying right side to the leading entry in the second row and it is the only non-zero entry in the fourth column. So this form of matrix is called reduced row echelon form. Similarly, we can check this matrix. It also satisfies all the conditions of reduced row echelon form. And this is the third example, and it also satisfies the conditions of reduced row echelon form. Now we will solve a few examples, and we will have to find the rank of the matrix. So this is the matrix, and we have to evaluate the rank of this matrix. So in solving these matrices, we can interchange the rows or columns with each other. And in this example, uh, we will see this is 0, 1, 2, this is 1, 2, 1, and this is 2, 7, 8. So we will replace or we will interchange first row and the second row, right? So this is our first row 1, 2, 1, and this is our second row 0, 1, 2, and this is our third row 2, 7, 8. So interchanging these rows or columns will not change or alter the properties of the matrices. And we have to find out the rank of the matrix. So we have to simplify these matrices and we have to transform these matrices to the upper triangular form or upper triangular matrices. Then we can see if we have a row of complete zeros, then we will be able to evaluate the rank of the matrix. So this is the first entry which has to be made equal to 0 and it is already 0 as a result of interchanging the first and the second rows. So one step of eliminating this entry has been reduced. Now we will have to convert this entry equal to 0 and this entry and this entry they have to be equal. So let's multiply the first row with minus 2 and subtract it from the third row. So this is the operation and after that we will have 0, 3, 6 and this is our new third row. So 1, 2, 1, 0, 1, 2 and 0, 3, 6 and let's try to make this entry equal to 0 and we have to multiply the second row with 3 and subtract it from the third row. So this will become 0, 3, 6. This is also 0, 3, 6. So the new third row will be equal to 0, 0, 0. So clearly we have got a row of complete zeros. So the rank of this matrix will be equal to 2. So there are two non-zero rows. That is, there are two linearly independent rows. So the rank of the matrix is 2. So let's check this matrix now. Uh, this is our first row. This is our second row. Now let's multiply the first row with 2 and subtract it from the second row. So it will become 2, 4, 6. This is also 2, 4, 6. So after subtraction, we will have 0, 0, 0 as the entries in the second row. Now we have only one row whose entries are non-zero. So the rank of this matrix is equal to 1. Now let's check this example. Okay. So convert this matrix to row echelon form and we have to convert this matrix to upper triangular matrix. So let's interchange some rows or columns uh, for simplicity. So let's transform this matrix and interchange the first column with the third column. So this is our first column 2, 0, 1. This is our third column 1, 2, 3. So this entry is equal to 0 now. Now let's make this entry equal to 0. Multiply the third row with 2 and subtract the first row from the third row. So we will have 0, 4, 5 as the entries in the third row. So 2, 0, 1, 0, 1, 2 and 0, 4, 5. Now we can check that there is no direct relationship between the second row and the third row. If I multiply the second row with 4, these entries will be equal, but this entry will be equal to 8 and this entry is equal to 5. It means if we try to make this entry equal to 0, this entry will be non-zero, and as a result, we won't have any row of complete zeros. So that's why all the vectors in this matrix are linearly independent, and so the matrix rank will be equal to 3, or we can say that this is a full rank matrix. Okay, so that is all about our today's lecture, and in this lecture we have learned how to evaluate the rank of a matrix, and how we can um, transform the matrix to row echelon form and reduced row echelon form. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.